let's go to number 4. So we're on the applications in business worksheet 2-1 or 2.1. Says a linear cost function is C at x equals 5x plus 250. So what is the marginal cost and what does it represent? Well, the marginal cost has to be that 250. You're paying that regardless. Okay, what does it represent? Well, we talked about marginal cost being, all of the things that are associated with owning a business, electricity, rent, things like that. What is the, good to see you. What is the C at x intercept? Well, that's the y-intercept. So that represents the marginal cost. Okay, so A and B are basically the same thing.
Wait, so the marginal cost would be the 250, not 5?
Oh, did I go backwards on that? I might have.
I put 250 would be like this.
Oh, yeah. I'm sorry. Darn Mondays. Marginal cost is the 5. What does it represent? It costs us $5 each thing to do. C at x, or C-intercept is the y-intercept, which is 250, and that's just your what your costs are. I'm sorry, I went backwards on that. Then find the difference between doing 50 versus 51 units. Okay. So all I can do, what I can do there is I'm going to go, just using the calculator, 5 times 50 plus 250, and then 5 times 51 plus 250. So $5 difference. What does it represent? I mean, we're just basically a $5. It costs you $5 more to create one more item. Okay. What is the cost of producing one more item if 50 are currently being produced? What is it if there are 100 that are currently being produced? Okay, so we've already answered the first one, but what is it if we go from 100 to 101? Plus 250 versus 5 times 101 plus 250. And it should be just the same thing. It's a $5 difference between the two. Okay? That's just kind of how you do that. Nice linear equations. All right, let's C at x, the cost, 5x plus 250, and R at x, that's the revenue, right? It's 27x. All right, so write a profit function. So let me get rid of these. So let's just go, because we're going to have to use this. Y equals 5x plus 250. And then let's do y equals 27x. Okay, and then if I wanted to create profit function, so it's going to be our costs. So 5x plus 250 minus 27x. 27x. Okay, so you could say it's y equals negative 22x plus 250. So what is the marginal profit? Okay, what is the slope of the profit equation? So our slope of our profit equation would be y equals negative 22x plus 250. So there's our slope, just subtracting the two. So it seems that as x increases, it's very likely that your profit's going to could get bigger. There's going to be some sort of fulcrum. Interpret the marginal profit. The marginal profit, kind of look at it as we're going to get to a point where we're plugging an x value in, and it's going to get so large that we're making more money than it's costing us to spend at the thing. And I'm not a big fan of number 5, how that's represented, so I won't be hitting a problem like that. Number 6 says, company charting its profits notices a relationship between the number of units sold X and the profit is linear. Okay, if 200 units are sold, result in a $3,100 profit, and 2,500 results in a $6,000 profit, write the profit function. Okay, so let's get rid of this. So I'm given 2 points. Agree? We're given the point 200, comma 3,100. We're given the point 250, comma 6,000. How do I make the equation on Desmos? How do I go for that? Yeah, make a table. So hit plus, make your table, and then plug your values in. So 200, 3,100, and then 3,100, and then, oops, down here, and then 250, and 6,000. And then remember on Desmos, we have x1 and y1, so that's fine. So I go y1. I have to use that tilde, which is under the alpha underneath the letter n. And then mx1 plus b. So we find that we have a linear equation of y equals 58x minus 8,500. So a company is charting profits, notices a relationship between the units sold and the profit, linear, 200, blah, blah, blah. Write the profit function for this company, find the marginal profit. And I'm not sure. I'm good with we just get to that equation. So that equation comes from our 2 points. Okay, and then a widget manufacturer incurs a cost.
Wait, so what's the equation?
It's going to be y equals 58x minus 850. So you have your m and b that it automatically gives you. Does that make sense? Cool. All right, so the manufacturer incurs costs for a widget being C at x, which is the same thing as y equals, and the revenue is 85. Where's our break even? So if you clear both of these out. So I'm going to go y equals both of those. Y equals 35x plus 1650. So you'll have to eventually find that. Get that purple. And then the other equation is y equals 85x. All right, so you just kind of have to scroll down until you figure out where about they intersect. The nice thing is once you do that, if you tap on them, you're at the right region. So once you have made 33 of these widgets, then you are making $2,850 or $2,805. That's the break-even point. That's the same point on both of the equations. So if you move this over and you zoom in on it, so it doesn't really, it's hard to kind of fathom where it's at exactly. But that's our break-even point. That's where the 2 lines cross each other. So 33, I create 33 things. I'm not making any money, but I'm not losing any money. So if I make more than 33 items, then I'm going to start making more money. If I make less than 33, I'm losing money. So how many widgets to break even? 33. The manufacturer sells widgets for $12 per unit. The fixed costs are $1,600 and the variable costs are $8 per unit. Write the equations of the cost and revenue functions. Okay, so we can do that. So we have $12 per unit, so that's going to be our slope. So y equals 12x. And then we have a fixed cost of $1,600. And then the other one says variable cost $8 per unit, so y equals 8. And if we go back towards home, we should have 2 equations someplace here. There we go. Are these going to cross? Or they're going to cross down here. Yeesh. So the break-even point, yeah, am I out?
Why wouldn't it be y equals 12x and y equals 8x?
I just realized my error right as you said that. So, oops. That should be plus 1600, right? Is that what your question was? That's going to make so much more sense. Thank you. So our break-even point is if we create 400 of our items, a company brings in $4,800, which associates all the costs. So that's our break-even point. If we make more than 400, we're making profit. Less than 400, we're making less than profit. So appreciate you looking out for me. And then number 9, company manufactures and sells widgets. The selling price is $54.90 per widget. The total cost function is linear. The costs amount for $50,000, for $2,000, and $32,000. Okay, so they try and frustrate you on this one because they give it backwards, but I'm going to go to the table first. So we have $2,000 for 50 to make 50,000. And then 800 for 32,120. Cool. So then I can go with Y1, find my tilde, MX1, plus B. Okay, so there's that equation. So we're going to go Y equals, Y equals, M is 14.9, X plus 20200. Okay, so that's the exact same line we have, which is great. And the selling price, $15.40 per widget. So Y equals 54.90 X. So again, we're going to try and, those are my two equations I'm going to deal with. I can just get rid of both of those. We have this break-even point somewhere in here. Click it. So at 505 items, our company is bringing in $27,724.50, which is our break-even point. If we make more than 505 items, we're making profit. We make less than that, we're losing money. And that, my friends. Cool? All right, we're going to spend a couple days on 2-2 and give you some time to work on some of these. Sweet, and they actually have the answers on 2-2 at the backside. All right, so the graphs below, you have supply and demand. So let's kind of just talk about supply and demand curves. So this could be a demand, and this could be a supply. So what we want to do is we want to eventually get to a point where we put the two together. The fulcrum where they cross each other is going to be important. They often call this P, they call this Q. So it's the same label, and yes, that's X and Y if you didn't like that. But then it says, and I realize that your graph is pretty bad, but I bet you we can kind of get close to this. It says how many units Q are demanded. So I'm looking at my demand graph when the price is 100. So this is price, this is quantity. Okay, so if the price is 100, we're going to go 100 over, and then we're going to drop straight down. So I think it might be pretty close to, does that look like 700? Am I right on my math? 200, 400, 600, 800. So you're just kind of just referring to the graph. We don't have the equation for that, so we can't just plug it in. So you have to kind of interpolate, meaning you're taking the inside data to take a look at what the results would be. So I went from the 100, traveled it over this way, and come straight down, and I realized the graph is not the best to look at, but we can get through it. And then how many units Q are supplied? How many items Q are supplied when the price is 100? So we go to the supply graph. When P is 100, so again, we're going to come like over this way and then drop straight down. So again, if this is 100, 100, is this also 100? Ballparking it. Now, if you look at the answers, how many Q items are supplied? Q items are supplied. Price is 100. Golly. Okay, if I come over. Oh, okay, I didn't come over far enough. My graph I just looked at. So this is about 350. Now, if you look at the answers between the two, problem number one, they said the answer is about 650. Okay? There's a big old range on that. I mean, especially I give you a cruddy graph to look at, and so deal with it. And then B, I'm thinking it's like 350-ish, but they're saying about 300. And so again, it's just some things that we're looking at on the graphs. So you're coming around. I think you guys could give you time to work on this worksheet 2.2, and I think if you knock out 1 through 7, and you got plenty of time today. I mean, we got 25 minutes, if I did my math right, to get you through that. Cool. Happy to help you.